Alright, so this video is going to go through just the basics of isotopes, not only what isotopes are, but also how to calculate isotopes, as well as the average mass of an atom based on the different isotopes that we find occurring. Just a review of some of the basics that we should already know. The first is the idea that every atom has two numbers associated with it. Right? We have an atomic number here, which represents the number of protons in an atom, as well as we have the atomic mass, which is going to represent the number of protons and neutrons in an atom. Remember, each proton has a mass of 1, each neutron has a mass of 1, so they add up to equal 40, and then the atomic number is just the number of protons. So again, as a review, what we know is that the number of neutrons in an atom is going to be equal to here. It's going to be 40 minus 18. So it's going to be my atomic mass minus my atomic number. And so with that, that's going to be equal to 22. So the number of neutrons that I would have in this atom would be 22. Add that to 18 protons, and that's going to be give me a mass of 40. Isotopes, as we saw in the lab, are something that is a little bit different for each element, something that we haven't talked about obviously up till now, where different elements actually have a number of different variations of themselves. So isotopes are atoms of the same element, but these elements now have different atomic masses. So examples of this would be argon, which we just saw, has a number of different isotopes. It has argon 36, argon 37, argon 38, argon 39, and argon 40. And actually the stability of these atoms is going to be dependent upon their isotope. So obviously argon 36, argon 38, and argon 40 are all stable elements, where argon 37 and argon 39 are actually radioactive or unstable forms of the same atom. So if we look at this, isotopes are pretty much atoms that have the same number of protons. So they're all argon. So what that means is that every single form of argon has to have the same number of protons, has to have 18 protons. So if we look at all of these, and what I would encourage you guys to do is, once I'm done here, to pause this and write down all these examples. All these argons have the exact same number of protons, 18, 18, 18, and 18, where each of them now have different numbers of neutrons. So argon 36 has 18 neutrons, 37 has 19 neutrons, 38 has, forgot to change that. Argon 38 has 20 neutrons. Argon 39 has 21 neutrons. And argon 40 has 22. Little mistake. But what I would encourage you guys to do, so these are atoms of same protons, but now they have different numbers of neutrons depending upon their atomic mass. So their mass, 36, 37, 38, tells me the number of neutrons. So they all have the same number of protons, all have an atomic number of 18. If I could write, their atomic number for all of them is 18, but now their mass is something that's different. And so because of that, they have different numbers of neutrons. So again, pause the video here and go ahead and write down those examples just to give you a view of what it means to have different isotopes. Now, isotopes, basically, this is the explanation as to why every atom on the periodic table doesn't have a whole number for the atomic mass. Basically, argon has a mass of 39.948, and so why isn't it 40? Why isn't it rounded to the nearest number 40? Well, basically, the atomic mass of an atom is based on what's called the abundance, or how much of each isotope is actually found So atomic mass is based on the abundance of different isotopes. So this indicates which isotope is the most abundant. So if we look at argon, while it has more than just these three isotopes, there's actually even more. These are the three most abundant forms of argon: argon 36, argon 38, and argon 40. Now if we look at their abundance, 99.6% of the argon atoms are argon 40. 0.337% are argon 36 and 0.063% are argon 38. So if we look at the abundance, argon 40 is clearly the most abundant. It is the one that naturally occurs more often than any of the other ones. And so what we see is that the mass, the average mass of argon itself right here, is going to be weighted closest towards whichever is the most abundant. So because the mass is closest to 40, that tells me that argon 40 is the most abundant form of argon out there. So let's look at an example of how we would actually find the average atomic mass based on the number of isotopes that we find. So go ahead and pause the video and write down this example. Now, here's what we do. Basically, we take the number of each sample, so 79, and we multiply it by the mass of that sample, 24. So let's do that. So we're going to take 79 multiplied by 24, and what that gives me is going to be equal to 1,896. I'm going to do the same process for the other two isotopes. So I'm going to take 10, multiply it by 25. 10 times 25. That one's pretty easy, so that gives me 250. And then I'm going to take 11 and multiply by 26. And that's going to give me 286. And so then what I'm going to do is I'm going to take all these numbers, so I'm going to take these three numbers, and I'm going to add them up. Gives me 2,432. Now, the last part of this is I'm going to take that value, 2,432, and I'm going to divide by my total number of samples. So my total number of samples is going to be equal to 79 plus 10 plus 11, which is going to be 100. So I'm going to take 2,432, and I'm going to divide that by 100. And what that's going to give me is that's going to give me the average atomic mass. So what I see is that's going to be equal to 24.32. So my average atomic mass of argon is 24.32. Or I'm sorry, magnesium. It's 24.32. Which this average actually makes sense because if you remember, I have magnesium 24, magnesium 25, and magnesium 26. And basically all the isotopes that are there, other than 24, are actually larger than 24. So 25 and 26 are larger. So that should make this number a little bit higher than 24. But obviously, magnesium 24 with 79 samples is the most abundant. So basically, it should be closest to 24, which it is. Lastly, then, if we look at another element in its isotopes, we look at neon. So neon has three main occurring isotopes. It has neon 20, neon 21, and neon 22. So based on the abundance of the isotope of neon, what do you expect to be the mass of neon to be closest to? And so looking at this, because 90% of neon is neon 20, we would expect that mass to be closest to neon 20. I also have neon 20 and 21, or 21 and 22, much smaller percentages of both of those. And so my mass should be just a little bit above 20, so maybe 20.1 or somewhere around that value. It's going to be larger than 20, again, because my other isotopes, neon 21 and neon 22, are both greater than neon 20. All right, so hope that is just a quick breakdown of what isotopes are, what it means to be an isotope, and also how to calculate an isotope, average atomic mass, and how to understand how the mass tells us which isotope is the most abundant.